Hi everyone, this is Siddha, and in this video I will talk about the dplyr package and the associated skills that are used in this package for data manipulation. We will work with the data of COVID cases that you can download from the description of this video below. So this data set contains more than 60,000 observations that has a record of the date of reporting, then the day, month, and year COVID cases, the deaths from COVID, country, geo ID, country code, and population and continent. So we will learn how to use the select function, filter function, summarize function, and other functions from the dplyr package to manipulate this data set. So let us start. Let me first set the working directory and let me import the data set. Since the data set is in Excel format, I use here the read Excel library and I import the data set and save it as data. So here is the data. We can have a look at it by just running the head function. So if you see the results in the console, you see that it has variables, date reported, day, month, year, cases, and deaths. So we can start with the functions from the dplyr package. So before that, we call the dplyr library. We load the dplyr library. If you have not installed this library, you can install this by just typing install.packages and inside bracket within inverted commas dplyr, and you can run this code. So I have already installed this, so I will just call the library. So the first function that I'm going to illustrate here is the select function, which is used to select the variables or the columns from the data set. So the various columns or the variables in this data set are date reported, cases, dates, country. So these are the column names or the variable names. So the select function is used to select the number of columns or the select the variables from the data set. So a specific function here is the pipe function, pipe function. So that can be typed in Windows by just pressing Ctrl Shift and M. So this function just connects the earlier function to the next function. For instance, the first function here is to take the data set named data, and then the next function is, after that, it selects three variables. So this piping function just connects one function to another function, so in an order. First the calculation of this first functions are done, then the calculation for the succeeding functions are done. So we can use this function as many times as we like by just connecting the lines of course together to produce whole summary statistics of the data. So for instance, if I type here data, means the data set, and Control Shift M, then so it just calls the data set, and then another function select. Okay, select. So let me select one variable only, cases. So if I run this, so it just selects the single variable called cases. So let us run few examples of this function, and by selecting the variables, I'm going to save the output as a new data frame. So the name for the first data frame that I want to give is data1, which is given by data, then select and the name of the variables, date reported, country, and cases. So if I run this command, it selects these three variables from the data and saves it as a new data frame, data1. So let us see, or let us run this line of code and see the data1 data frame. So we can have a look of at this data set. So it is 3 columns only that is according to the code we have written here, data, and then select only 3 variables and save it as data1. So another example, data, then select 175. So this selects the first column, 7th column, and 5th column, and save the data frame as data2. Let us run this code and see. So it has the first, 7th, and 5th column of the original data set. So another example, if we write select 1 to 5, it selects 5 columns from first column to 5th column. Let us run this line of code and let us have a look at data 3. So first to 5th columns of the original data set. So if we write this exclamation sign before the list of variables or the list of columns, it will ignore those columns and copy all other columns. So if you write this, it discards column first, column 5th, and selects all other columns and save them in the data frame data4. Okay, let us see data4. So the data or the columns start from the 6th column of the original data set only. So column 1 to column 5 are ignored. So few other example, if you put a minus sign before a number, it drops that variable or that column from the original data set. So this command is simply data and then select -1, means drop first column. So if I run this line of code and see the object data5, so it is data frame, so there is no first column from the original data. So another example, if I write here minus sign before a range of values, for instance 1 to 5, it drops column 1 to column 5 and save the original data frame as data 6. So let us run this. Data 6 now only has columns from the 6th position of the original data set. So you can drop separate columns by putting a separate negative sign before them. For instance, if you write select -1, -3, it drops first and third column. So you can run this line of code and see the result. Even you can put a minus sign before the name of the column or the name of the variables. For instance, if you run like this of code, it drops the population variable from the original data set. And finally, you can select all the numerical variables from the data. So for that, select if command can be used from the dplyr package. Select if, and inside bracket is .numeric. So it selects only the numerical variables from the original data set. So in place of is numeric, you can use other conditions also. So let us first run this and see the result. Control enter. If you press control enter, this line is executed, and let us see there are 9. So only numerical variables are here. So this is especially useful when you are going to calculate correlation matrix. So for calculating the correlation matrix, only numerical data are required. So in that case, you can select all numerical variables and find the correlation matrix. So let us now go to the second function from the dplyr package, which is the filter function. So while the select function is used to pick up the columns, the filter function is used to select the rows or the cases based on certain criteria. So few examples here. The same logic here, the pipe function. First, the name of the data set. So go to the data set called data, and then filter from the dplyr package, and the condition is population is greater than 1 million. So if I run this line of code, what it does is that it selects only those cases which has a population of greater than 1 million from the original dataset data and save it as data 10. So let us run this. So now we see that originally there were 61,900 observation, but in data 10 there are only 47,000 observation. Means all other observations that had a population of less than 1 million have been dropped. So you can connect two conditions. For instance, population greater than this is million, so I think it's a billion. So this is 1 billion, population greater than 1 billion, and continent Asia. So if your variable is a categorical variable, you should put double inverted commas for the values of that category. So now we wanna filter only those rows or only those cases that are from Asia and that have a population of greater than 1 billion. So if you run this line of code, the dataset data 11 has only 699 observations. So only the countries China and India have been selected, because those are the countries that have a population of greater than 1 billion. So a few other examples. We can again connect two conditions by using comma, and this refers to the end criterion. So cases greater than 10,000, dates less than 200. So we can run this code and see the result. Again, or condition, cases greater than 1 million and dates greater than 2,000. We can see the result, and we can even filter the data from Nepal only. In that case, we use the condition country equals to Nepal. So if I run this and see the data frame data 15, so this is the data from Nepal only, because we have used the condition that we wanted the data from Nepal only. So here is the result, the data from Nepal only. So in this way, the filter function is used to select the rows or to select the cases based on certain criteria. We can use more than one criteria depending on our purpose and the need of analysis. The third useful function from the dplyr package is arrange, which is used to arrange the numbers of the data set or the columns of the data set either in ascending or descending order. So the arrange function, if we use arrange function, just arrange function, it arranges the data set in ascending order. So arrange cases arranges the data set in ascending order of the number of COVID cases. So if I run this and see the result, data 16, so the number of cases, so number of cases should not have negative sign, but unfortunately here the number of cases have negative sign. Anyway, the number of cases are arranged in ascending order now. So the last row, highest number of cases, and the first row, the lowest number of cases, which is negative in our case here. So in the same way, if we want to arrange the data set in descending order, there are two tricks. The first one is you can write DESC function. For instance, DESC des arranges the data set in descending order. Now the highest number should come first. So if I run this and see data 17, so the highest number of dates must have come first. So 4928, 3935, so highest number has come first. Or if we can even use the arrange function, but a negative sign before the name of the variable. So if we put a negative sign, it also arranges the variable in descending order. So if we put a plus sign in arrange function, it means ascending order. If you put a minus sign, it means descending order. So we can look at date 18, and the number of dates is in descending order now. So this is the third useful function. The fourth useful function is the mutate function, that is used to generate a new variable while doing data manipulation. So mutate means generating new variables. So for instance, we can create a variable called population million, population yum, which is just the population divided by 1 million. So this is the new variable mutate. Mutate is the function from dplyr package. Population popum is the name of the variable that we want to give, and this is the formula for defining the variable population divided by 1 million. So if I run this line of code, so it creates a new variable called popm, and it saves the original data frame along with this new variable as data 19. So if I see there are 19, now there are 12 variables, and the last variable is the variable created by us. So in this way, the mutate function is used to create a new variable. So you can find the variable of cumulative sum of cases by just mutate. So cum, this is the name of the variable we want to create, and we can put any name, but the formula is cum sum, means cumulative sum of cases. So we can run this and take a result. In data 20. So if we see the cum variable generated, so this is the cumulative sum of cases. So 746 plus 298 is 1044. 1044 plus 113 is 1157. So let me go to the next function, that is summarize function. Summarize function is used to calculate the summary statistics from our data. So for instance, we want to find the summary of cases, COVID cases. We can just use data and then summarize mean. So mean is the name of the summary that we want to give, and you can put any name here, but the formula is mean of cases. So if you run this line of code, the data 21 is just a single figure of the whole series of cases, and it is the mean value. So just one mean value of, or the grand total mean value. So we can summarize the data by groups, and for that we use the group by command. So for instance, let us assume that we want to know the COVID cases, mean COVID cases by continent. So in that case, what we do is we take the data set data, then the piping function, pipe function data, then group by continent. So this makes a group of continent, and then we summarize the average number of cases by using the same formula we used before. So mean is the name that we give, but the function is mean of the cases. So if I run this line of code, so it groups the data by continent. It first groups the data by continent and finds mean value within each continent and reports it in the form of table or data frame. So data 22, so data 22, so now not the universal or grand total mean, but mean cases or mean COVID cases by continent. Mean COVID cases by continent has been reported here. So this is the use of the group by function. So we can have other few examples. For instance, we want to calculate other summary statistics, maximum, minimum number of cases. So in that case, we first group by the data by continent and then summarize. Cases means number of cases. Mean of the cases, minimum cases, maximum value of the cases, standard deviation, median, 50th quartile. So we want to find a number of summary statistics by continent. So if I run this line of code and see the result, data 23, I think. So data 23. So we have grouped the data first by continent. We have summarized the data. We have summarized the data by cases, means number of cases count, mean cases, minimum cases, maximum cases, median and 50th quartile. So median and 50th quartile are same, so they have same answer. So standard deviation has not been produced here, so I will talk about this issue later. Anyway, the group by and summarize function can be used together to produce whole summary statistics by groups, summary statistics by categories of the categorical variables, and you can present or you can save it in the form of table or data frame. So let us have a few other examples. Let us find the sum of cases by continent, sum of cases by continent. So we first group by continent and summarize as total equals to sum of cases. So this produces the answer in the R console here, because I have not told the R to save this as a new data frame. So I haven't given any name here, so the answer comes up with console, and it just produces the number of total cases and saves it in the total column. So a few other examples. In the next line of code, I want to first call the data and then group by the date reported. So I want to add up two values of the same day if there are any. So I group by date reported, and then I want to summarize the data, and I want to summarize the total number of cases as the sum of cases. So it adds the COVID cases of all countries for a particular day, and I want to create a new variable called cumulative total, which is simply given by the sum of total defined in the previous step. So if I run this line of code, what we get here is just the data grouped by date or day. So data 24. So just data grouped by date, and total number of cases worldwide on that day, and the cumulative total. So the cumulative total in the last date available in this data set, which is 2020 December 14. So this is the number of cases, and this is the cumulative number of cases as per our code. So a few other examples. So now I want to combine the function of dplyr package. So in this line of code, I just call the data, and then first I filter. So filter country equals to Nepal, and then I group by month. And then I summarize total equals to sum of total cases. So this produces the output in data 25. So here just the data from Nepal and the monthly total, because I have first select the data set for Nepal only, and then I have grouped by month and find the total of each month. So the slice function is another useful function in the dplyr package that can be used to pick up the rows depending on the values from the first column, which is often called the index column. For instance, if you write slice height, and for instance n equals to 3, you just pick up the 3 observation from top. If you run data then slice tail n equal to 3, only 3 observations are picked up from the bottom, and you can even take a random sample by using the slice sample function. For instance, if I just write data then slice sample n equal to 10, it randomly selects 10 items from the data set. Let us have a look at it. So it first selected from 2020 July 2, 2020 May 23rd, 2020 June 21. So it has picked up the data randomly and make a random sample of size 10. So few examples for combining the functions of the dplyr package. So let me combine the functions. Data, I call the data, then select function, I select date reported, continent, country, and cases, 4 variables. Then I use the filter function to filter the countries from Asia only, continent equal to Asia, and then I group by country, and then I summarize the data as the total number of cases. So I use the sum command. sum of cases for each country in South Asian region. So for that, I select few variables only, then I filter the data, I group the data, and I summarize the data. So if I run this, the output comes here because I have not saved the data in a specific name. So it has find the total number of cases for each country over the period of time. So then another one example, in this example I select the data, then select 4 variables grouped by date reported, then I rank the data according to the number of cases. So create a rank variable which is given by rank of negative times cases. So negative times cases means a descending ranking. The highest number of cases is given first rank. And then I filter rank, so I want to pick up top 10 countries only. So I pick up rank, or I pick up filter function, and the condition for filtering is rank less than or equal to 10. And then arrange, finally arrange function, arrange date reported and rank. So if I run this line of code and see there 26, what we see that, so what we see here is that for each date, the the function has picked the top 10 countries. For instance, for 1214, the top 10 countries for the number of cases. So rank is 1 2 3 4 5 6 7 8 9 10. So for each date it has picked 10 top 10 countries. With regard to the number of cases, it just picked the top 10 countries and put it in an arranged form, so that if you want to know the top 10 countries in terms of COVID cases per day or per each day, we can have a look at it. So finally, we can even combine other package functions to this dplyr package functions. So in this example, I want to first manipulate the data and then plot the data in a bar chart or any other chart. So I combined this output with ggplot object or ggplot functions. So first I take data, then group by continent, summarize total number of cases for each continent, and then I introduce the ggplot function and ggplot. So to introduce the ggplot function, you have again continue using the piping function, Control Shift M, and then ggplot, x-axis continent, y-axis total. These are from our manipulated data set. So the total variable is not available in the original data set. Here we have just defined this total variable as the sum of cases. So then the geometrical property is geom:, and we use the classic theme here. So if I run this line of code, we can see a bar chart over here that shows the summary statistics, or that shows the total number of cases by continent. So in this way we can use the filter function, we can use the select function, we can use the group by and summarize function from the dplyr package to manipulate our data, to summarize our data, and to extract something meaningful from our data. So in the next video, I will talk about using the ggplot package for producing powerful graphics in R. If you like this video, please Do not forget to subscribe my channel and do not forget to like and share this video.